The Oracle Autonomous Database, the world's first self-driving database. So relax. Everything's automated. Human error is eliminated. A revolutionary new technology called machine learning enables the database to protect and repair itself without ever having to stop. The database automatically responds to cyber attacks and prevents data theft. In a world striving to build self-driving cars, Oracle has built a self-driving database, fully automated, ever vigilant. Your data is safe. In the Oracle Autonomous Database Cloud.
Please welcome to the stage Executive Vice President, Database Server Technologies, Oracle, Andy Mendelsohn.
Okay, good morning, everybody. It looks like we've got a full house here. This is terrific. And what we're going to do is we're first going to have Pat Sullivan come out here. Pat runs Accenture's Oracle business in North America. Come on out here, Pat.
Thanks, Andy.
And Pat is going to talk to you for a few minutes, and then I'll come on next.
All right, great. Pat. Thanks, Andy. All right. Well, to kick this off, I want to tell you a story. So 22 years ago, I'm sitting in my dad's office, and to put this in perspective, my dad's he was a university basketball coach, and there was this big monitor thing on his desk, and I said, "Dad, you got a computer on your desk?" My dad looked at me, and he just had this huge grin on his face. He was so happy, and he goes, "Pat, I haven't even used it, and it's been here for 7 months." I go, "All right, well, Dad, look, you know, between my 4 sisters and I, this is a way in which you can get in touch with us, and the way that we're communicating is through this thing called email." And so he got a little excited, and he goes, "All right, well, help me set it up." So I put in all my sisters' email addresses, I put mine in, I put the keyboard in front of my dad, and I say, "Okay, let's get ready. You can send your first email." So my dad sits there, and he looks down, looks back up at me, he does it again, and he goes, "Pat, why aren't the keys in alphabetical order?" So now that same man, my father, he's got a smartphone, a tablet, 2 laptops, and he just finished publishing his 2nd book. So if my father, the human, can make amends and embrace technology with the machine, then so can today's enterprises in this post-digital area that I'm going to talk about. So our destination today is autonomous, and over the next 20 minutes, I'm going to take you on this journey where we explore what's happening with data, the trends that are going to create more data, and really put this data to work to drive new revenue streams, competition, and new businesses. And so right now, we're in this middle of an explosion of data. And you know, there's always been 2 common data sources. There's been consumer data, and then there's been enterprise data. And these used to be pretty obvious until kind of what's happening today. And each of these are growing at unprecedented rates today. And so there's a statistic out there that says we're generating over 2.5 quintillion bytes of data every day. Have you ever wondered what 2.5 quintillion looks like? Well, check this out. It's a 2, a 5, and a whole bunch of zeros. And to put this in perspective, let me give you a couple points on just what big numbers look like. So a kilobyte, okay? A kilobyte is 1,000 bytes. That translates roughly to about 17 minutes ago, and I was backstage having a conversation with Andy. A megabyte, that's 1,000,000 bytes, and that was 12 days ago, and I was on my computer booking a flight to be here with all of you. Now, a gigabyte, which is 1,000,000,000 bytes, that was 32 years ago, and I wasn't here, I was in school, I was in 6th grade. Now, if you go to a terabyte or 1,000,000,000,000 bytes and put that against time, that was 31,710 years ago. And I think that's probably when my dad was working to invent the keyboard. So to get to a quintillion, you need 2.5 million terabytes, or millions, trillions. And that's a lot of data. And that's data that we are creating every single day. So the question you might be asking yourself is, where is all this data? So let's take a look at that. So I call this the data minute. And since I started talking about 6 minutes ago, let's look into what happened in one of those minutes. So if we look at this and explode this out, nearly 60 million text messages were sent in a minute between messaging apps and WhatsApp. But 188 million emails were sent. And what's interesting about that is 104 million of those emails are estimated to be spam. More gifts were served up than searches on Google, and more people swiped left and right on Tinder than people who logged into Facebook. But most importantly, over $1 million, or just about $1 million, was actually spent online in a minute. So when you think about the data that's coming from that, it's pretty monumental. And most people would consider what's on this slide to be consumer data, but not companies that are taking this data, putting it to work, and personalizing the data to create offers individualized for us. They would consider this the golden data. And that's part of this new world that we live in, both as consumers and as enterprises. So the best way to discuss this is actually through this report that our company, Accenture, does every year called the Accenture Technology Vision. So we've been producing this vision for over a decade. It comes out every year, and in each tech vision, we look at different trends that are shaping out in the enterprise. Some of these trends are a few years out, while others are happening right now. And when we look at these, we try to understand what innovations are really going to drive these trends to work out into the market. And the Tech Vision for Oracle is something that we published just about 5 months ago. And so this year's Tech Vision for Oracle is centered around the emergence of this post-digital era and how we're moving beyond the adoption of these digital tools to a new generation of technologies. And we'll talk about autonomous and how these technologies and innovations are applying to the business where businesses can differentiate themselves within the marketplace. So very simply, digital technology is no longer this competitive advantage that we used to talk about and help companies achieve. It's the price of admission. And this new set of rules for businesses in this post-digital world, it requires the use of powerful new technologies to innovate the business models, personalized experiences for customers, and customized products, services, and even people's surroundings. For example, with extended reality, all on demand. But with these new rules come new and deeper responsibilities. So in other words, post-digital is about these 3 tenets: individualization, instant on demand, and momentary markets. These are 3 critical elements for businesses in the post-digital era. And they're all backed by, guess what? Data. And so we surveyed over 6,500 executives from companies with revenue over $6 billion. And here's some interesting findings. So 85% of these businesses, they believe that customer demands are moving their organizations towards customized and on-demand delivery models. The same number say that integration of customization and real-time delivery is the next big wave of competition. But what they all said is that it's going to take them 3.5 years to get there. And in order to deliver this on-demand, these custom products, and these services in real time. So to differentiate in this emerging post-digital market, companies have to understand the combination of being able to know people at the holistic level where they can instantaneously understand demand, but then be able to meet that demand instantaneously. Again, it's all about data. And these will enable companies to deliver as needs change at a moment's notice. So an example of this is actually how Adidas and Siemens are working together. Adidas is on this initiative where they want to customize every single shoe. So you can go to adidas.com, you can customize colors, different logos, where things are, but they don't have the warehouse in order to do that, and that's where Siemens comes in. So the 2 companies are working together to create these things called speed factories to be able to customize and do this on demand and get shoes out to their consumers. All right, so we know that data is exploding, and a tech vision characteristics certainly showcase that data is being used as this weapon for disruption and a creation of new revenue streams. And in order to access, manage, store, secure, analyze, and integrate all of this data, it requires a deeper look. And this is where we test the value of humans working with machines. So every day at Accenture, we've got a group of close to 20,000 Oracle data professionals across the globe. And they're helping our clients process over 60 billion transactions, over 3 exabytes of storage on Oracle databases. And so as a result of the work that we do here, Andy and team reached out to us 2 years ago to beta test the autonomous data warehouse. And we really liked what we found. And so in our testing, we were able to insert 500 million rows in 3 minutes and create data marts in mere minutes without using core Oracle DBA skills. But that was 2 years ago. So given the explosion of data and the continued maturity of Oracle's offerings, our Oracle engineers at Accenture decided to put autonomous to the test. And so our findings are really simple. And I'm going to go through this for the next few minutes. But Oracle's autonomous database and data warehouse are solutions that thrive in this post-digital world. We're launching this new report at the end of this presentation that you can download and read, which goes through all the results that I'm about to go through. All right, so there's 3 key pillars that we're going to go into. The first one is speed. Does it perform? The second one is money. Is it cost effective? And then the third one we measured is value. Will it deliver business results? So, should we jump in? All right, let's do it. Okay, so speed. Testing performance, honestly, can be as much of an art as it is a science. And our focus was not to break records when we did this testing, but to simulate what we typically see in the work that we do for traditionally Fortune 500 companies. And so there's a few key details that went into our methods before I go into what you see on here. So what we did on the first 2 configurations, the leading cloud provider and OCI, is we installed Oracle Database 19c. And the concept that we had here is that most of our clients have their own licenses. So we took a bring your own license approach to this. Now, what we could not do is install Oracle Database on autonomous. And by the way, if we could, it wouldn't really be that autonomous. But we accepted the installation of what Oracle chose for 19c on autonomous, despite what our Oracle aces would really like. But keep in mind that when you do the installations, that takes time. With autonomous, it just happens, and it happens in minutes. So we also use Swing Bench. Swing Bench is pretty much what the entire industry uses to generate loads and performance testing for Oracle database workloads. And then we have an OLTP data set that we tested with that generally we use in a lot of our clients. So pretty active, lots of transaction, production type grade data set. And then we ran these tests on the 3 different clouds over 50 times for an hour. And we did this at all times during the day so we could watch any variations based on cloud usage or network or that concept of the noisy neighbor effect. And then we took the averages of all of these tests, and that's what we published in our research paper. Now, we tried to make each of the clouds that you see behind me look alike, but not all clouds are alike in the shapes that we can buy. So each configuration had the same number of CPUs, and remember, 2 CPUs on a non-Oracle cloud is equivalent to 1 Oracle CPU or OCPU, okay? Now, memory was fairly similar. However, that's why Rosie the robot from Jetsons is up here, because on autonomous, that's automatically allocated for you, and it's just done. Again, it's autonomous. And so we selected solid-state disk on the third-party cloud. We also did that on OCI. And this is where the storage or the disk size is where we're limited. So on OCI, the smallest shape you can get for a disk is 6.4 terabytes on the NVMe. And then the last thing is we've implemented thousands of Exadatas for our clients. And so we knew with autonomous, because it's Exadata in the background, that this was going to kind of be like an Indy car and a stroller derby, and it was going to be a little bit of an unfair test, if you will. So what our engineers decided to do was add another shape. And so we did this with a 2 OCPU shape, just to kind of test our hunch and to see what was going to happen. So with our testing environment set, we ran the test over 50 times for each hour, and here's what we found. The non-Oracle cloud completed 65 queries per hour. OCI, 19 times more queries with the same exact workload. And then the autonomous data warehouse just screamed by running 184 times more queries with the smaller configuration of autonomous running at 37 times. So essentially here, we have proved that the autonomous data warehouse has phenomenal performance. But the question we ask next is, what is that going to cost us? So let's look at the money slide. So there's a lot of information on the slide, and the first thing that your eyes are going to go to is that bottom row and looking at the total cost. But let me take you through a few things. The cloud prices here are published prices based on the configurations and the terms that we selected. We assumed that bring your own license for the Oracle database, but there's still support costs that go with that from an annual basis. And so the support costs on OCI and the other cloud, we based that on 19C with advanced security as the only option. On autonomous, when you bring your own license, the infrastructure and the support costs are built into that service offering. But here's some key points. Regardless of how many queries these clouds can run, the pricing represents the total costs for running Oracle database and mission-critical OLTP data sets. An autonomous data warehouse includes all database options that Oracle have, including high availability, or rack. So if you wanted to add compression or partitioning or rack to the other two configurations, your price gap starts to widen significantly, favoring, of course, autonomous. So time, like I stated before, is not factored in here. That time to do the installations on the other two clouds or to create Ansible scripts, if you will, but you've got to update those every time new patches and releases from Oracle come out. So what you see here is autonomous is clearly price competitive, with the total cost being 13% less on that larger configuration, and then on a smaller configuration, 2.5 times less than the other cloud. So we've proven that Oracle's autonomous data warehouse is really performant, and the total cost is lower than other clouds where you can run Oracle database workloads. So now I want to look at the value, and I want to kind of put these two together, and let's see what we got. So here's the value. So how much do you want to pay for every transaction that you run is really the question. So if you expand out the total cost and the queries by hour, we wanted to understand what it would cost to get the work done, as we all want to spend less time to do more. And again, remember what we talked about data and the growth of data. To be able to query that quicker could give you a business advantage. And so if you just think about data, I've been up here now 15 minutes or so, and in that time, we've added 520,000 new terabytes of data just in that time since I've been talking. So being able to run more queries could be the difference between your company being disrupted or your company disrupting the competition. So we know the number of queries, we know the speed, we also know the annual cost per configuration, the money. So we explored the value of running these queries by hour and by query, as you can see up here. So the total cost to run OCI with the same configuration is roughly half of the other cloud, or 97% cheaper when you look at it as total cost by query. And if we were to look at this from a different perspective, the autonomous data warehouse did not let us down. So the cost per query on a large configuration is 200 times cheaper. On a smaller autonomous configuration, this is really interesting, it's only 1% of the cost to run that compared to the other cloud when you look at it per query. So another way to look at this, which could make a lot of sense for all of you, certainly for me, is literally when you put your money on the table and you look at it. So let's take at it from this perspective. So it makes a lot of sense, if you will, when you look at it from this area. And for each query on a leading cloud provider, you're gonna pay 20 cents per query, okay? On OCI, it's half a penny. On the smaller configuration of Autonomous, it's a quarter of a penny. And then when you look at it on that larger configuration, getting work done, it's a tenth of a penny. So it's pretty phenomenal what Andy and team here at Oracle has done. So if you're an enterprise and you're leveraging data to help your business grow, you really should be leveraging innovation that's going to yield the largest results as we show. And these are tests using data sets as well as what we do with our clients in that production manner. All right, now there's one more thing here I want to talk to you about, and this is that patching for security. So if you went out and Googled what it would cost for an average data breach in 2019, you're going to see this thing called $3.92 million on average. So one data breach, $3.9 million, right? That's just the average. Just think of what it would cost for your enterprise. And obviously, bigger enterprises, potentially a bigger cost. So we believe at Accenture that securing your data is not only critical, it should never be a choice. And what we like about Autonomous is that it defaults to security right with the solution. And so anytime Oracle sees a potential threat that comes in with their cloud security operations group, they immediately start to apply that threat into a patch. And the first thing they do is they dynamically update Autonomous. But then as all of us know, if you installed Oracle 19c, even on infrastructure as a service, you're still liable to have to patch that. So enterprises can take days, weeks, and we've seen months to apply these patches. And so if you think about that with the sensitivities around not having that patch and what it could cost you, you really can't put a price tag on doing that. So this further adds to the total cost, which is hard to realize and put up here, but we do believe that being able to remediate that potential loss of business as soon as it happens, is important. So any loss of customers' data generally results in a business loss as well. Okay, so I want to continue this and build on this. So these were the three characteristics of our tech vision. And with the three characteristics and the stellar performance results that we saw from the research that our team did with Oracle's Autonomous offerings, it's really important to understand how this is actually being applied. And so trust and responsibility is a key thing whenever you're dealing with vast amounts of data. So data served up by machines, right? But we as humans need to be making sure that we're using it responsibly. So I'm going to give you a few ways how Accenture is applying these autonomous technologies to solutions that we implement with our clients across three major areas. All right, so the first one is what we look at with industry solutions. We have a solution called the Accenture Life Sciences Cloud. And this is a solution where we aggregate clinical trial data. And most of the large pharmaceuticals use this solution today. And so basically the data is flowing from all sorts of different source systems into one platform. And what this allows the pharmaceuticals to do is use data as a way to create new applications to the different governing bodies, such as the FDA in the United States. And what the FDA has done is they've now allowed the use of historical data to be used in these submissions to essentially improve the times in which drugs are approved. So the ability to analyze this data through complex algorithms and produce this scientific data is why we're leveraging Autonomous in this solution. The data certainly needs to be trusted, but we need to be responsible with it. And when lives are on the line, that's pretty important. The second example is back office transformations. We're doing a lot of these at Accenture today with our clients. And in transformations where clients are moving their back office applications to SaaS, Accenture, we're offloading this historic data, which at times could be anywhere from 15 to 30 years of historic data. And we put this on Autonomous. And we do that because it works. And the management of this platform is essentially hands-off. We can focus on transforming our clients to what they need. And so this is rich enterprise data, however, that's never really been leveraged in a way in which we can personalize it with other data to create these new offerings for other businesses and clients that they have. So again, this data also needs to be trusted, but we have to be responsible with it. Now, the third one is what we call the migration of the old. We're starting to see a trend right now with our clients where they're offloading their legacy data warehouses onto the autonomous data warehouse. So Hearst Communications is one of our clients. They're a mass media business headquartered in New York. And you know, the thing I like about Hearst is they're not waiting to be disrupted. They're moving their data to a platform that can query it faster than anything else can to create these momentary markets. And believe me, that matters at Hearst based on the business that they have. And again, this data, it needs to be trusted, and we have to be responsible with it. All right, so let me wrap this up for you. I can clearly say that Oracle runs best on Oracle Cloud. Andy's team has done just a remarkable job of bringing great innovation to the market and bringing solutions that can take on this massive growth of data. And so, you know, the thing I'll leave you with is this. Andy's team, they make excellent products. And it's Accenture's job, it's my job, to make it work for our clients. So I've got one question for you. Are you autonomous? Give me a call. Our team will help you get there. All right. All right, thanks so much. You can actually download the study at the link here and also our Tech Vision. And right now, I'd like to bring Andy back out to take you through all the great innovations that his team has been working on in data management and the next generation of autonomous.
Okay, thanks, Pat.
Thanks, Andy.
Okay, so let's get going. And what I want to start off with is just a little bit of a discussion about what it is that we in Oracle database development are focused on these days. And you know, everybody thinks Oracle's just talking about cloud, and that's all we do is cloud, 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 but it actually is not exactly accurate. So the big thing we are focused on, number one, is today, I think it's very well recognized that we have, you know, the best database software technology out there. And our focus is that 10 years from now, we want that still to be the case. We want not just to be the best, we want to be, you know, 10 years ahead of everybody else. So we have a huge focus in just building core software, core database software that runs everywhere. It runs on premises, it runs in our cloud, it runs in other clouds. And you know, that's number one priority here. We want to be in the lead for pure database technology for the long term. Number two, of course, we're very focused on engineered systems. We started working on Exadata about 15 years ago. It's pretty hard to believe. But that technology is really important on-prem. You know, you saw from the last presentation some examples of the performance of Exadata-based infrastructure that we use on our cloud. And of course, you can use the same infrastructure on premises as well. And that technology, one of the big things we're doing there is, and there's going to be an announcement later today, is we are making that technology more cloud native. You know, today in our cloud, there are these boxes, Exadata boxes, but a year from now, Exadata is going to be more like a virtualized technology where you can push a button, and on our cloud, you'll get a virtual Exadata that's composed on the fly out of the component parts, the storage and the networking and the compute servers that you need. So we're doing a lot of work there. And then finally, of course, autonomous database. You all know about that. You just heard a little bit about autonomous database in the last presentation, and I'll talk about what we're doing there. Okay. So let's just focus on the software innovation part first. First, a little review. I think most of you understand we've gone to this new release model where every year we ship a new version of the database, and the name of the release is basically the last two digits of that year. So 12CR2 is the last of the old style naming that we shipped in 2017. And then 18C and 19C are effectively what would have been called 12CR2 patch set 1 and 12CR2 patch set 2, with 19C being the terminal long-term support release of 12CR2. So that's sort of where we are, okay, in the release process. And I just wanted to review really quickly what we did over those last 3 releases, because as customers, many of you are using Oracle database releases before 12CR2, as you upgrade, of course, to 19C, and that's where all of you should be going now, not any of these earlier releases, you get the benefits of all the innovation in all these earlier releases. 12CR2 in particular had a lot of innovation in it. The big new feature we did there is something called sharding. And sharding is not for most of you. It's mostly designed for really extreme distributed transaction processing systems. The original sharded systems were like Amazon.com's manually sharded Oracle databases to run e-commerce all over the world. And that was sort of the early days of sharding. Now we've automated sharding so that you don't have to understand that there are a different database in each of the different locations in the world. We take care of that for you. There's a really nice use case for sharding also. If you are a global business and you have customers in different countries in the world, and there are regulations that say the data about the customers has to stay in a data center in that country, sharding is really good for that too. You can create a shard for each of these countries that need to have local data, and you can follow the regulations around that. We've done a lot of work around multi-tenant. That was new in 12CR1. Multi-tenant has become the foundation of everything we do on the public cloud. Autonomous Database is using multi-tenant. Our Fusion SaaS applications all run on top of Oracle multi-tenant databases. NetSuite's moving there, Salesforce moving there. And then on premises, customers are building private clouds using multi-tenant as well. So it's a really valuable technology that's very flexible. It fits really well with what people want to do in both private clouds and public clouds. And then, we're working on enhancing all the technologies, the in-memory technologies continuously getting enhanced, and that'll be going on for years. Online database encryption is really important. You have a lot of data that's not encrypted. Everything needs to be encrypted nowadays. And it's now very easy to do that because now, while your production system is running, you can encrypt your data in the background online without any downtime. So that's a really nice feature in 12CR2. 18C, as I said, you can think of it as the first patch set to 12CR2. The big focus was just on quality. Fix lots of bugs, fix security bugs. We did some small number of features as well in that release. You'll see things like Microsoft Active Directory integration. Before, you couldn't integrate the database directly with your Active Directory server. You had to go through some intermediary. That's no longer needed starting with 18C. And we did some other things. Private temp tables are really nice for developers if they want to have a temp table just temporarily during the life of, say, a stored procedure or something like that. That's a nice feature. And then 19C, which is our long-term support release, we actually did a reasonable amount of innovation in this release. Some of it was for cloud, and some of it is just for typical use cases that customers have. The first one was for IoT. So with IoT data, a lot of it's like sensor data from car telemetry, et cetera. This data is not really that valuable. So if you lose some data points here and there, nobody really cares. It's not like a banking transaction or something like that. So in 19C, when you create a table, you can now tell us it's one of these kind of tables that's collecting less valuable data. And if you tell us that, we will, when you say commit, we'll get the data to disk eventually, but the focus is really on performance. So we'll buffer all your loads up, your insert statements up in memory, and we'll eventually get to disk. And we pretty much will do, but if the system will crash, we might lose a little bit of the sensor data. It doesn't matter because nobody cares. So the reason we do that is because in exchange for that, possibly losing some data, you can get 2-3 times faster load performance without rewriting your code. Just standard SQL insert statements against this kind of table will just run much faster. Active Data Guard updates, this is a really important feature. A lot of you are using Active Data Guard. You know it's for read-only sort of reporting workloads, so your standby database can now be valuable. It's not just standing there waiting for the disaster to happen, right? So unfortunately, a lot of these read-only workloads sometimes really aren't read-only. They do a few updates. And so if you have one of these read-mostly workloads, which is, say, 95% read, 5% updates, you can now run them against the Active Data Guard standby. And it's all transactional. It's all transparent to your applications. It makes Active Data Guard much, much more useful. So that's a really nice feature. Automatic indexing I'll talk about later. That's part of our autonomous database self-tuning capabilities. SQL query of object stores. This is another feature that we built originally for Autonomous Data Warehouse so that you could easily load your data warehouse by taking files, putting them into the object store, and then using standard SQL statements to just insert data into the data warehouse by selecting it from the object store files. It turns out customers are now, and I'm sure many of you are looking at deploying object stores on premises. Object stores have become, in a lot of ways, a replacement for Hadoop HDFS. It's a way of storing lots of data at really low cost. And so we decided to make this ability to query the object store available on-prem as well. And then finally, JSON. 12CR1, we added JSON support. It's, of course, as you know, very popular with developers. We're continuing to enhance that, and we'll talk about what we're doing in the next release, 20C, around JSON a little later. OK, so why 19C? As I mentioned, this is the long-term support release everybody's been waiting for. So if you're on 11GR2, 11204, whatever, and you've been waiting for the next big long-term support release, this is it. Everybody should be certifying their ISV applications, moving their databases to 19C. It'll be supported all the way out to 2026 with extended support. It's sort of a no-brainer. This is, at this point in time, don't move to any of the, don't move to 12CR2, don't move to 18C. Now is the time to go to 19. OK. OK, so in this presentation, I have a few of these myth statements. Because when you go out there, most of you understand Oracle really well. But the more junior members of your organizations, the developers often, they've grown up in this world where there's a lot of mythology going on around relational databases. And they've been using these less powerful relational databases. They're using Postgres or MySQL. And all the limitations of those databases are thought to be limitations of relational databases. But of course, they're not. They're just limitations of those products. So one of the things I want to do today a little bit is debunk some of these myths, just so you're armed and dangerous when these developers come and tell you, oh, Oracle can't do this, and Oracle can't do that. Well, it's so the first one I wanted to mention is this one. This is the one you hear from a lot of the Hadoop community, the big data guys. They're like, OK, we want to do all these analytics against our data. And of course, relational databases can't analyze unstructured data. They can't do machine learning models, et cetera, et cetera. They can't scale. And so this is the first one. Let's talk about this one. So of course, relational databases were purely relational 30 years ago, when we just supported numbers and columns with numbers and dates and strings. But over the years, relational databases have become multi-model databases. We support relational models. We support JSON as a data type. We support XML, spatial data, graph data. Of course, key value data is a very simple subset of relational data. So the developers can get what they want, which is they want their popular open source tools to write code in all the languages in Java, JavaScript, Python, et cetera. We give them all that. And we give them powerful open standard SQL to access all these different data types. The popular cloud guys out there, they give you all these, they basically encourage you to take your data and fragment it across 9 different cloud services, one for each of these different kinds of data types, because they don't have powerful database technologies that can really do multi-model really well. So we give you powerful query across these data types. So in the case you have a workload that actually requires spatial data and ERP data, very common. You can use one database for that. You don't have to fragment your data across multiple cloud services. And of course, you get transactions. You don't have to do anything. You just say commit, and you're done. With these other cloud vendors, you have to spread your data around all these different data sources, cloud services. If you want to do a transaction, you're sort of out of luck. Maybe they have two-phase commit across them. They usually don't. Security, you're at the mercy of the weakest security of all these different databases you're storing your data in, and you're fragmenting your data. That's the worst part. And so with our approach, analysts get what they want. They want to be able to run rich queries to understand the business. And if the data is fragmented all over the place, they have to do lots of ETL to consolidate the data back together again so they can run queries, okay? That's not an easy way to go. So with Oracle, you can keep the data consolidated so you can have a nice global consistent view of what's going on in the business. Of course, the ops people also get what they want. They want reliability, they want security, they want scalability, and with Oracle you get that as well. So this is my, my first myth-busting slide, okay. Number two, this is another thing you hear from developers. Oracle doesn't really fit into what we're trying to do with our cool new microservices applications and private clouds, et cetera. And here, the answer is multi-tenant. I mentioned earlier that all of our cloud services, Autonomous Database Service, Fusion SaaS, are all based on multi-tenancy. And multi-tenant is also the right technology to be using on premises when your developers are running in private clouds. Whether the cloud is based on VMs technology or it's on the latest Kubernetes technologies, what you want to do is give each one of your developers or organizations who are building a microservice their own private pluggable database. So what they tell, I guess the popular cloud vendors tell your developers, for each one of these microservices you're building, you should have a separate database because you want it to be totally isolated from all the other microservices. And then you can upgrade things and patch things independently. It's really great. So what we tell our developers, with Oracle, that doesn't make any sense. You don't want to give each microservice its own Oracle database. Instead, give a pluggable database to each microservice. And that gives the developers sort of what they want. They want isolation. They want their own private schema. They want to be able to develop and enhance their application independent of the other microservices. And so our advice to developers is use multi-tenant, just like we use it in the cloud. It works really well. And okay. And then you get, of course, all the scalability and reliability and security of the Oracle database. Okay. End of my two myths section. The next release, 20C, is in development now. It'll be coming out towards the end of the year, early next year, just like all the other annual releases. In this release, we've done a few things that are sort of interesting. The first thing up there is native blockchain tables. So you've all heard about blockchain, right? It's this technology that was built originally to support Bitcoin. And what it does is it lets you have essentially an audit trail that's tamper-proof and trusted, et cetera, using encryption techniques. And one of the popular cloud vendors out there just created a new service. They call it Quantum Ledger Service. And it basically is this blockchain technology where again, it's like the ability to have a table of information that is tamper-proof. And so we said, this is pretty stupid again. It's like, why do you need another cloud service just so you can have a blockchain table? So with Oracle 20C now, when you create a table, you can say, I want this table to be a blockchain table. It's just part of the DDL create table statement. And when you do that, it uses all these standard technologies now that people originally built for Bitcoin for making a tamper-proof table. So this table looks and feels like a SQL table. You can query it like any SQL table. You can do inserts into it like any SQL table. But you can't do deletes. You can't do updates. It's tamper-proof. It's encrypted. We use the same techniques for hashing the blocks so that new blocks are a function of the old blocks, and we can detect tampering, et cetera. So that's new in 20C. And we think that about 95% of what people are thinking of doing with these distributed blockchains can actually be done with this simple kind of table infrastructure. AutoML. This is another really important thing. So again, one of the things people are confused about Oracle database is we actually do have built into Oracle database a very rich set of machine learning algorithms that we've been working on for 15 years now. And one of the problems in the machine learning space is that most analysts don't understand machine learning algorithms. And it's very, and there's just a shortage of people that really understand this technology. So what we're trying to do with auto ML is to make it possible that most business analysts will be able to use some of these machine learning algorithms to build models that they can use then for predictive purposes. So in 20C, we can now, with auto ML, we will look at sort of your data. You will give us sort of, the predictions that you want. Here's a set of target predictions. Here's the data. This is what we think the right outcome should be. It's sort of a training set for the machine learning algorithms. And then we will look at what the right set of columns in your tables are that should be used for the algorithms. This is called feature selection in machine learning lingo for you. And then we'll look at various algorithms that we have available, and we'll actually figure out what the right set of features are required and the right set of algorithms can be used to get the right set of predictions. And we'll do this automatically for you, and then your analyst can choose from different choices of algorithms. We'll say this one looks best, but you could use this other one as well. So that's what we call auto ML. We think this is really important because we really want to help you leverage the value of your data by letting more and more people be able to help capture the value. It shouldn't just be a few data scientists who are off in the corner of some department, but all the analysts should be empowered to be able to use this technology. The last two features are also really important. JSON, of course, is very popular, and in 12CR1, we started supporting JSON documents, which were textual documents, character strings. In 20C, we are now also supporting a binary representation of JSON, which not surprisingly lets you query JSON documents, traverse the complex documents, do updates really fast. So I don't have the numbers here, but this is like 2x, 3x, 4x faster for update intensive or traversal intensive JSON operations. And then the last feature, persistent memory store, is really important. I mentioned earlier, one of our goals, of course, is we want to build database software that's the leader 10 years from now, and by far, right? And one of the big disruptive technologies that is now out there is this new persistent memory technology that Intel went production with earlier this year. Intel calls it Optane. And I'm sure most of you have never heard of this thing. But this is really important because all the standard algorithms for databases were invented when disks were really slow. And we did all this work to cache data in buffer caches to avoid IOs to disks. And all those algorithms are now obsolete when you have a database that can fit in persistent memory. And so we are working really heavily on two things. We have evolutionary technology. So in 20C, you can now store essentially a file in persistent memory and use that to store data in your database. And when you do that, we will essentially use that directly, like you become sort of an in-memory database. And the persistent memory technology is relatively easy to use, but when the system crashes, you still have to deal with interesting failure conditions. So it's not trivial to have a database support this kind of technology. And in 20C, we have the first sort of evolution of Oracle to support persistent memory. And then we are working longer term on a project to actually re-architect a lot of the guts of the Oracle database for persistent memory. We think this is one of these things that if you don't do it in 5 years, you're going to be a legacy product. So that's a really important first step in persistent memory support. OK, so that's sort of a short summary of what we're doing with the database software. As I mentioned, all these innovations are in the software, can run on-prem, can run in clouds, can run on Exadata, et cetera. Exadata is evolving as well. Earlier this year, we came out with the X8. The X8 is just like all the previous generations of Exadata. You get more compute performance. You get more storage, all at the same price. And then we added one new thing. A lot of customers have data that gets cold after a while. And they were thinking, it's too expensive to store this data that I hardly ever query in my Exadata storage. So I'll move it off the Exadata to some lower cost storage tier. But when you do that, of course, you lose the ability to query the data. So one of the things we did with the new X8 is we have a new tier of storage that you can buy called XT storage. And we wanted to make this storage really cheap. So when your data gets cold, you can just move your data to this storage tier that's on the Exadata. You retain queryability, but you sacrifice performance. To lower costs, we just ripped all the flash memory out of the Exadata. And we also made it possible that although the data is queryable, if you don't want to use Exadata Smart Scan to offload your queries, you can tell us that, and then we won't require you to buy the Exadata storage server software either. So this is a really nice alternative for those of you who have lots of data in your Exadatas. Some of that data is getting cold. You can now store it at much lower cost with the XT storage. The other new thing, which we are announcing today, and I don't want to take all the glory here from Larry will be talking about this at his keynote this afternoon. The X8M is a new version of Exadata that's coming out this month, and it is quite a radical departure. So there's two things new here. Number one, persistent memory is now embedded in the storage hierarchy of an Exadata. So transparently, you will get the performance benefits of persistent memory. And one of the things you're going to get, and it's in that little lower left-hand corner of the slide, you're going to get 19 microsecond IOs on this box. So that's pretty fast. The other thing we're doing here is that Ethernet has basically caught up to InfiniBand. It now supports RDMA, which is one of the secret sauces of InfiniBand that let different servers in a cluster access the memory of other servers in the cluster. And InfiniBand also now has the performance. We have 100 gigabit Ethernet, every bit as fast as what InfiniBand can do. In fact, faster even. So this new X8M is going to be the first generation of Exadata that is based on Ethernet. Now, of course, for those of you who have Exadatas that are based on InfiniBand, we will continue for quite some time producing Exadatas also with InfiniBand, so you can grow your existing Exadata configurations. But for the new customers or people that are deploying new Exadatas, the X8M will be the future direction. And I mentioned earlier that in the future, Exadatas will be natively provisionable on the cloud. Well, you can see why that's going to be possible. This Exadata X8M is now built using Ethernet. Ethernet, of course, is what we use for networking on the cloud. And so it's a real prerequisite, it's sort of the beginning of our move to an Exadata that's completely provisionable out of resources that are just standard compute, storage, et cetera, on a cloud. Okay. And just in case you don't know how fast 19 microseconds is, we put some charts here to compare what is the Exadata X8M performance versus what you get on various clouds, on AWS and Azure. And yeah, it's really fast. Okay. Now, this one I hear sometimes from customers. There's this myth that Exadata is a lock-in product. So it's a bunch of Oracle hardware, so it must be locking me into something, right? And one of the things people don't quite understand, and it's our fault, we didn't communicate this really well, is that when we create the Oracle database, we have these developer APIs. SQL, of course, is the most important of all the developer APIs we have with the database. When we sort of factor the product for what works in the cloud and what works on-prem and what works on Exadata, the APIs are sort of sacred. We want to make sure that any application you build with our developer APIs will run everywhere. It'll run on-prem, it'll run on an Exadata, it'll run in our cloud. Now, of course, Exadata has really great performance, and it really scales well, and it's really reliable. So that application will run better, on an Exadata. But it'll run, if you take it off an Exadata, you can run it anywhere. And so that's one of our big goals, to keep Exadata be an open product. And in contrast, of course, you all know about IBM mainframes and how these applications that were written 30 years ago are completely locked in and you can never move them ever. That is a true lock-in product. Exadata is really a much more open technology. And then, of course, the cloud vendors, these guys, like Amazon, have all these proprietary services, those proprietary databases I was talking about earlier. You write your applications to any of those APIs, those applications run in one place. They run in their cloud, nowhere else. And so I think one of the things you have to be aware of as we go into this cloud era is that you really want to think about portability. You want to think about using open standard APIs, and for data management, SQL is the open standard API. And that's really what you want to build your database applications around, is open standards, not proprietary APIs. Okay. Last topic, cloud. Of course, we are working on cloud, and Autonomous Database is the big initiative we have there. And again, just to contrast what we do versus the other popular cloud vendors, we have a self-tuning, self-driving service. They have still manual tuning services. We have the Oracle database at our core, and you get all the enterprise reliability and security and scalability that Oracle has. They have open source databases that are really nice, but don't compete with Oracle. And then, of course, they have all these specialty databases we talked about earlier. They have 9 different specialty databases on Amazon. Each one lets you fragment your data and run your graph stuff over here and your blockchain thing over here and your analytics over here. We don't think that's a really good idea. Anyway, what we are doing is a self-driving database. We build in enterprise class security and reliability using Oracle database technology. And we have a converged engine or a multi-model engine that really can do all kinds of different workloads for you. You don't have to learn all kinds of different APIs. You don't have to use proprietary APIs. You can just use industry standard SQL for all your data management. This is the architecture sort of at a high level of Autonomous Database. And we have 2 separate Autonomous Database services. One is called Autonomous Data Warehouse, and that's what Pat was talking about in his experiments that he showed you earlier. Autonomous Data Warehouse is for all your analytical use cases, like a data warehouse, data mart, data science, data lake, et cetera. And Autonomous Transaction Processing is for everything else. It can do pure transaction processing workloads. It can do mixed workloads of transactions and analytics, which is pretty much everything you do, 80% of what people do. And at the core, all of these services are identical. There's a big Exadata infrastructure at the bottom. We build an 8-node rack cluster on the Exadatas. We use Oracle multi-tenant on top of that to share the resources across multiple organizations that provision a database. And then for Autonomous Data Warehouse, we take advantage of the Oracle in-memory column store technology to make it possible for you to do incredibly fast scans. We offload the column store scanning to the Exadata storage as well, which is why we can get so much better performance like what Pat was showing you earlier. And that's all done transparently. You don't have to know anything. You just say, give me 5 CPUs of Autonomous Data Warehouse. And with 2 terabytes of storage, you push a button, and you get this highly tuned, high-performance analytical engine for analytic-type workloads. For transaction processing workloads, it's a much more complicated world. There, you tend to use our standard row format, and that's what we do by default with Autonomous Transaction Processing, and use standard indexes to make things go faster. And that's a much more complicated environment to do self-tuning, and I'll talk about how we do that coming up. Okay. Of course, since we are now autonomous, we are doing the work that used to be done by armies of people. We still have lots of people too, but not armies. We have small little, platoons or something. And so to do the work, we have all kinds of algorithms at all the different tiers, some of which are classical machine learning algorithms, some are expert systems, et cetera, to do this autonomous capability, to automate various things. So the Exadata infrastructure, of course, is Exadata. So we've been automating the ability to detect hardware failures in Exadata for years. We detect hung servers, et cetera, in the database server as part of this service. We use something called the Autonomous Health Framework, which is also available on premises, to gather telemetry from all the database and look for anomalies and try to predict upcoming failures that might be happening. And then we do all the self-tuning around this as well. So this is a complete service where we do the whole thing. We manage the infrastructure for you. We manage the database for you. We do the self-tuning for you. And it's mostly all automated. Now, of course, there are all kinds of performance tuning features in the Oracle database that we haven't gotten to yet. But over the next 5 years, we will be making sure everything is automated from a self-tuning standpoint. We're now in production for about 1.5 years. We've got lots of production customers. And this is great. Well, you can still read the logos. That's good. And I just wanted to drill down into a few of the customers that give you a flavor of what the different customers are doing. So the way this slide works is the top row is autonomous transaction processing customers, and the bottom row are the autonomous data warehouse customers. And in the transaction processing space, one of the things you're first going to notice is like, I've never heard of these companies. Who are they? And so a lot of these customers are relatively smaller enterprises. The big, more mission-critical customers are still using Exadata Cloud Service. And so here, Jassy is an example of a customer. They do software for warehouse management, order processing, et cetera. They were on IBM's cloud. They moved to Autonomous Database. And as you can see, they're getting much better performance with Autonomous Database than they got with their previous cloud. Mestech is interesting. They do manufacturing software for helping companies optimize their manufacturing processes. These guys are most interesting because they're one of the early customers who are writing their applications on Azure and running their databases on Autonomous Database and using this integrated interconnect we announced recently with Microsoft around Azure. On the Autonomous Data Warehouse side, TaylorMade is an example of an enterprise company. They make golf clubs. You've, I'm sure, heard of them. And they had an existing Oracle database on-prem. They moved it to ADW on the cloud. We have a lot of customers doing that sort of thing. Hertz, BP, lots of customers have lots of these data marts. You just repoint the ETL at our cloud ADW. You repoint your BI tool at the cloud ADW, and you're in business. It's very easy to move data marts to the cloud. Heya is one of the bigger media companies in Latin America. They're based in Argentina. They were using Teradata on-prem. Over the last 1.5 years, they've moved everything off Teradata onto ADW and get much lower, they actually get much better performance at much lower cost. So that's a really nice story. QMP is a good example of a startup. We're getting a lot of startup companies who are discovering that ADW is an incredibly disruptive technology. They're in the healthcare industry. Their existing competition, of course, has this established IT infrastructure that's very high cost. They are able to go in and compete in the blood testing analytics market and be able to deliver results in hours that used to take weeks for their competitors to deliver. So ADW is a really powerful technology for disrupting markets. Okay, we have two kinds of autonomous databases now. Serverless is the original service that we came out with 1.5 years ago. It lets everybody sort of share this infrastructure in a cloud in a multi-tenant fashion. You can start at very low cost. Just give me 1 CPU, 1 terabyte, or scale up from there. Dedicated is the new service we just introduced a couple months ago. And this is for customers who are really big. They don't want to just have 1 data warehouse or maybe 2. They want to have 50 databases or 100 databases. And they're big enough now that they want to have the equivalent of a private cloud in our public cloud. So they can actually allocate their own Exadata infrastructure that's just for them. And in exchange for that, they get some isolation that they can't get with the normal serverless version of the service. And the big thing they get is more of the control that they're used to on-prem. So for example, if we want to do patching or we want to do upgrades, they get to decide when that happens. They have to give us a window of some sort, but they have control. On the serverless side, you're sharing this infrastructure with all your friends and neighbors from other companies. You can't really control that. So this is a service we think is where the enterprise customers are going to want to go. dedicated is a great way for them to go to get maximum isolation. Okay, automatic indexing. This is the new expert system we came out with for doing self-tuning. It does basically what a smart DBA will do. It learns all your SQL statements. It remembers the SQL execution plans. It remembers the runtimes of those plans. And then as your workload evolves, it looks for new indexes to be created that can make your SQL statements go faster, just like a good DBA would do. It tests it on the side, looks for things, looks for indexes that work well. When it finds something, it'll roll it into production. And the first time you run any new SQL execution plan that uses that index, we will compare the performance with the old plan. And if it's worse, we'll immediately go back to the old plan on the next execution. So this solves one of these really important problems that people have had for years, is like, suddenly my SQL query is going slower. It's using the wrong plan because I did an upgrade of some sort. Now that problem is gone, right? If any of these SQL execution plans regress, it'll run one time, and then we pull it back. So this is a really important technology. This is all sort of now part of autonomous transaction processing in the dedicated world, and it'll be coming out on autonomous transaction processing serverless. In fact, I think we're in preview mode now there as well. Okay. And with that, we're near the end here, and I wanted to talk a little bit about Apex. So how many of you actually know what Apex is? I'm just curious. Raise your hands. Oh, I'd say about half of you. Good. So Apex is this really one of our secret sauces of Oracle that the people in the know sort of understand. With Apex, you can build applications really fast without writing lots of code, and this is really important. You know, especially in the cloud world, the competition really believes that you need high-powered developers writing tens of thousands of lines of code to get anything to work on these clouds. With Apex, those of you who are in the know, you can build applications with 100 times fewer lines of code, often no code at all. You can develop things, of course, much, much faster if you don't have to write code. And so first of all, we're going to run a little video with some Apex developers who are going to talk about their experience with Apex.
We're building more things quicker, and they look better, and they perform on any device that we want to have them on.
Deploy data warehouse applications, permitting applications, survey applications, all using Application Express.
Point to any SAP table, take that data, analyze it in an Apex application, and then create the scripts to move that over to the Oracle ERP cloud.
They're able to use our application we built in Apex to fulfill all the needs of their workflow in one application. They don't have to go here to do toxicology, this for reporting the body. They don't have to worry about dealing with other information and providing reports to third parties.
Yeah, without Apex, it would have taken us
Weeks.
forever.
Okay, and now to give you a little proof of how fast Apex can build applications, I'd like to invite out Jenny Tsai. She's our VP of Product Management Database, and she'll show you.
Thank you very much.
She will build an app for you in a few minutes.
Okay, thank you
Take
very
it
much,
away.
Andy. Hopefully I won't flop here. So I am actually going to be showing you how to build a complete application using Apex 19.2, which is our very latest version. You could try it at tryapexnow.com. And I've downloaded some Airbnb data sets. This particular one is all the rental listings in San Francisco. And what I'm going to be doing is just uploading the data using Apex into a database in the cloud, and then creating an application without writing any code. The only typing that I will be doing is typing in the name of the table that I want to create using this data set. All right, so let's get started. So first of all, I need to sign into this Apex 19.2 and going into my workspace. Next, I'm going to use the App Builder wizard to basically walk through the flow. So again, I'm not typing any code. I'm going to go ahead and upload the CSV file, the spreadsheet that I downloaded from Airbnb. It has about 8,000 records, so not quite the quintillion records that Pat talked about, but enough to show you that there's some real data here. Apex went ahead and sampled some of the rows in the spreadsheet and determined the column types automatically. I'm going ahead and typing in the table name and just clicking a button to load data. And again, it's about 8,000 rows, so it should take maybe a few seconds to load. And it's writing into the database in the cloud. All right, so we've got 8,000 rows thereabouts. Next, I'm going to go ahead and click a button to tell it to create an application. And this will create basically a home page for us, along with a sign-on screen, plus a dashboard, an interactive report that allows me to edit the data, plus the faceted search page, which is the brand new feature with 19.2 Apex. All right, so I'm going to go ahead and by the way, it was smart enough to know that maybe I want to use the table name as my application name, so it typed it in for me already. There we go, voila. In less than a minute, I have a full-blown database application written by Apex for me. And it's created some of the pages that you see at the bottom here. Let's go ahead and run this application as if we're end users. So first thing it's going to prompt me to do is to basically type in my username. Okay, and I'm just using my developer username and signing in. Let's take a look at the interactive report, which is also an editable form. Okay, so here I can actually sort the data and even do some basic querying of the data. I can click on a button to edit the record and save it into the database. So we'll just pick one here and add a bit of data here. Of course, I could also delete records from here and create new records. All right, now let's take a look at the dashboard. Apex was smart enough to say there are certain columns that might be of interest, and it's chosen certain chart types for me. From here, I could drill down into specific rows by clicking on, for example, room type equals private room. It shows me all the records of that type. Now let's look at the faceted search. So what Apex has done is using some special algorithms to choose the best facets to use based on distribution of data, the number of distinct values, and it also uses the SQL grouping set clause to calculate the counts automatically for me for each of the values in the facets. So I'm going to go ahead and choose Bayview. Notice I have 183 records in Bayview. By selecting room type, Bayview is now reduced to 72 records that are relevant. Let's put in some minimum nights that I want to stay, so 1 to 3 nights. Click Go. And again, further reduction of the available rows based on filtering of the reduction of narrowing of the search. Next, I'm going to go ahead and choose the number of reviews, because I'm guessing that the more reviews a rental has, the more likely that people rented it and are happy because they're taking time to write a review. Hopefully they're positive reviews. And here I found one that says cozy private suite with separate entrance for only $78 a night. That's a bargain. I'm taking it. Thank you very much.
Thank you, Jenny.
Thanks,
Great.
Andy.
OK, so we're going to finish up now. Just do a few more slides, and we'll let you get on your way. So one of the big announcements Larry is going to make today at his keynote is something we're calling the free tier of our Oracle Cloud. And I'll just give you a little teaser here for the Oracle database part of the free tier. The big thing we're going to do is we're going to make Autonomous Database available to you for free. Not just free for 30 days or free for 1 year. It's a free forever offering. It's for developers, so we're going to give you sort of micro versions of Autonomous Database. You can do either ADW or ATP. We'll give you up to 20 gigabytes of data. We'll give you sort of a portion of a CPU. Sometimes you'll get up to 1 CPU. And you'll get the full functionality, everything there, Apex, SQL Developer, machine learning notebooks, et cetera. So that's big. That's something to let all the developers get our technology really easily for free over the cloud. Data safe, so Oracle, of course, Autonomous Database has by default all the data is encrypted. We do the security patching online for you automatically. Data safe takes care of the stuff that we can't do automatically. It helps you understand what the privileges that have been allocated to your users. It does auditing and captures audit trails and looks for kind of anomalous behavior in your database for you. It's a new free part of all the database cloud services that we have on the Oracle Cloud. Autonomous Database today is available on our public cloud in all of our various data centers around the world. And coming soon, sort of towards the end of this year, early next year, we will make Autonomous Database available at your data centers. Just like Exadata Cloud A customer today can run in your data center, you can run our Exadata Cloud service, you'll be able to run Autonomous Database service as well in your data center and form your own local cloud. And then finally, just from a vision standpoint, I mentioned earlier, one of our big goals here is that we don't want you to have developers writing thousands of lines of code to get anything done in our cloud. And so we are building on what we already have with Autonomous Database and things like Apex and auto machine learning to try to make your experience of your analysts and your data scientists really simple if they want to get value out of the data. And so things like ETL are just going to be rolled into Autonomous Data Warehouse. The vision is your analysts should just show us the data they want to deal with, the transformations they want to make, and we'll take care of all the movement of the data for them. We'll do the caching for them, et cetera. We will have a strong metadata catalog offering here, and it's being announced this week, actually, that we will use for this service. And then high-performance machine learning algorithms both in the database, like I mentioned earlier, and then we have open source algorithms that we call from our data science organization that will also be available here. So anyway, that's just sort of a visionary standpoint. So this is what we talked about today. We talked about what we're doing in the software space. 19C is here. All of you should be looking at moving your applications on-prem or your ISV applications to 19C. 20C is coming soon. Some interesting stuff there. Exadata, of course, is constantly being revved. And Exadata X8M is quite a new radical departure for Oracle for Exadata, where we are now moving to an Ethernet-based infrastructure with persistent memory. And then, of course, we talked about Autonomous Database. And with that, I'd like to close, and I'll invite you to come to some talks we have later this week where you can learn more details about all the things we talked about today. Okay, thanks for coming.